Hello, welcome to hacksOnTable. My name is Reinhard Krisam and today I'm gonna show you how to create this project. It's an STM32 F103 controlling an OLED via I2C. In this tutorial I'm gonna show you how to connect the OLED with the nucleo board with the STM32, how to create a CubeIDE project and include an external driver from GitHub, and finally how to write the software for controlling the OLED. So if this sounds interesting to you, stick with me and let's go. Okay, let me give you a quick overview of the hardware setup before we can start coding. First of all, there is a nucleo board containing an STM32 F103 that is connected to an OLED. And the connection is done via 4 cables. 3.3 and ground to supply the OLED, and SCL and SDA for I2C communication, means clock and data for the I2C communication. In this image, you see the real location of the connections between the nucleo board and the OLED. So you can use this image if you want to build this project by yourself. Well, that's it. So let's code. Right, now let's start coding. First of all, you need to create a folder where you want to put your project in. In my case, as you can see, there is an OLED tutorial folder on the desktop. Now, let's open the CubeIDE. Select the workspace, and the workspace can be the folder you created just before. In my case, the OLED tutorial folder on the desktop, and click Launch. You have to wait a bit. When it's loaded, the information center is shown. Here you select Start New STM32 Project. And now the target selector will be initialized. In the target selector, we click on Board Selector. There we type in the name of our board. It's the nucleo-F103RB. As you can see here, there's only one entry. That's the entry we select. Click Next. Now we have to input a project name. Just can name it OLED Control. Leave the rest as it is. Next. Select the firmware package. You can either use the version I use, 1.8.4, or the latest version, doesn't matter to be honest. And now you click Finish. Yes, initialize the peripherals in default mode, and yes, we want to open the configuration tool perspective. Now the configuration tool GUI will be loaded, or the configuration tool will be loaded. Here we have to activate the I2C module because we want to control the OLED via I2C. Therefore, we click on Connectivity, I2C1, and select the mode I2C. We can leave the parameters set as they are because in our case they are good to go. We are good to go. The only thing we need to change is the pin assignment, because activating the I2C module here leads the module to be assigned to the pins PB6 and PB7, but we want to use the pins PB8 and PB9. They are also capable to be used as I2C pins. Therefore, you just click on one of the two pins, for example PB8, and select the I2C functionality, I2C1_SCL. The tool is intelligent enough to also switch the other pin, means the SDA line. Well, and that's it for the configuration. We now must click this configuration icon or save the project. Here we want to switch into the C++ perspective, and now the configuration tool will generate the code. And voila, our startup code, our code to begin, is finished. Let's quickly build to see everything works well. Great, 0 error, 0 warnings, best thing that could happen. Now we need to include the external library for controlling the OLED, because we don't want to write the OLED driver from scratch. There are tons of drivers out there, and so I chose one, and I chose a driver from GitHub. I'll show you in a moment. It's an STM32 SSD1306 driver project. It's from a guy called Alexander Alexeyev, and I think this driver is quite nice. So to use this driver, you need to download it. Just click on the green code button here and click download zip. Okay, now here you see the downloaded and extracted folder. Inside of this folder, you see another folder called SSD1306. Open this folder, and here copy all files except for the test.h and the test.c file. Copy these files, go to your project folder, to your workspace folder. Here, open your project folder, jump into the drivers folder, and here we will create a separate folder which we call OLED. And now we have an OLED driver, an OLED folder in the drivers folder of your project, which is good because we will include the driver files in here. Just open this folder, paste the files, that's it. Now let's go back to the CubeIDE. In the CubeIDE, we just need to right click in the project Explorer and click refresh. Now let's open the drivers folder, and as you can see here, there's an OLED folder we created before, and there are all the files we pasted in. One important thing we have to do now is to update the include paths, because we insert a new folder, and therefore we have to add the path to this folder to the include path list. We do this by right click the project name, click on properties, there you select the include path, and here you see all stored include paths. Click on the plus icon, and now select workspace, open your project tree, go to drivers, finally select OLED. That's it. Now we added the path to the OLED to the include paths. Click apply and close. This message only means you have to rebuild that these changes have an effect. Okay. Let's try to rebuild. I'll bet there are some errors. They are, so no problem right now. Now the next step we need to do is to update or to configure the driver's configuration file. There's a file called ssd1306_conf_template.h, and this is the file we are now configuring or manipulating. So open this file. Okay. First of all, we have to change the used microcontroller family. We will use the STM32 F1 and not the F0. So comment the F0 and uncomment the F1 define. The I2C is already defined. Here choose a bus, I2C is defined, so we do not have to do anything. We do not have to change anything here. The I2C port is the I2C1 we've activated before, that's all fine. SPI configuration, you can ignore it because we do not use SPI here. The included fonts, leave all 4 fonts defined because maybe you want to use them later. And finally, we have to define the width and the height. The width of the OLED I'm going to use is 128 pixel and the height is 32 pixel. So just uncomment the defines and change the defines to the appropriate values. Good. Now, just save. Now we have to rename the file because the underscore template ending needs to be removed. So right click to the file, click on rename, and just remove this underscore template. That's it. Now let's have a look into the header file of the driver to see what's the problem. Yeah, the problem was that this SSD1306 underscore conf.h wasn't found at the last building because there it was named underscore template, or there was an underscore template in the file name. If we build this now, this red line should be, this error should be gone. Correct, this error is gone. Okay, let's continue. Let's scroll down to the function definitions in the header file of the Oled driver, or to the procedure definitions as it's named here. And here you have a list of all the functions you can call. The first function is the SSD1306 underscore init function. This function must be called at the beginning of the program to initialize the Oled driver. So just make sure to call this function at the beginning before you use the Oled driver. The next function is the fill function. This function will change the background color of the Oled, for example, from black to white. But after you call this function, you won't see any change on the physical Oled device. To really see a change, you need to call a certain function, and this is the function update screen. Every time you do some change to your Oled and you want to make this change visible, you need to call this function. You need to call the update screen function. Okay, and when we want to write a text, we can use this write string function. But if we want to determine a certain position on the Oled where the text should start, we first need to call the set cursor function. This function, as you can see, gets an x and y coordinate as parameter, so that the cursor on the Oled will be set to the defined position. And after we have called the set cursor function, we set the cursor set on a certain position, we can call the write string function, and then the text will start at the defined position. And to display this written text, to really display it on the Oled, we again need to call the update screen function. So that's it. That are the few main functions we're gonna use right now. There are a few other functions, but in this video we only concentrate on these functions. So let's go to the main. I've already prepared something here. As you can see, right after the start of the main function and right after the initializing of the peripherals, especially of the I2C, we can start using calling the Oled functions. First of all, we call the init functions to a function to initialize the Oled. Then we want to change the background color from black, means no color, to white, means the pixel is turned on. And to see this, we call the update screen function. Good. And to give you a live overview of the changes on the Oled when I step through it in the debug mode, I will now insert a small view where you can see my physical Oled device in the left lower corner. Okay, now you should see the live view of the Oled in the left lower corner. Before we start the debugger, we set a breakpoint at the line where the init function is called. This is done by just double-click the blue area beside the code line. Then we need to start the debugger. This is done by clicking the bug icon. But before we can debug, we need to initialize or configure the debugger because it's a new project. Just click the debugger, activate or check the ST-Link serial number checkbox here, and click to scan. Make sure your nucleo board is connected with your computer. Then after clicking scan, your connected nucleo board or the ST-Link on the nucleo board serial number should be displayed here. That's it. Click apply and click OK. And now the debugger will start. It may take some time, but it will start. Okay. If you have set the breakpoint at the appropriate line and click play or resume, the program starts at this init, stops at this init line. And now always keep the live view of the OLED in mind, or have an eye on it, and let me step over the functions. After we initialize the OLED, nothing changed. Then we fill the background color, or we change the background color of the OLED, and again, nothing changed. But now, when we call the update screen function, the background color will physically change on the OLED device. Right, that's it. You created the project, you downloaded the source code for the OLED driver, you configured the OLED driver, and now you created a small demo application, and everything runs well. Good. Now click to the stop icon to terminate the debugging process. And the next step we're going to do is to display a text on the OLED. And what do we need to do now? We just need to comment out this, or comment these two lines where we change the background color. So just mark these lines, click to source and toggle comment to comment these lines. Just save. Go back to the header of the OLED driver. And as I told you before, we need two additional functions. The first function we need is the set cursor function to set the cursor at a defined position on the OLED before we start writing the text. And to start writing the text on the OLED, we need the write string function. Okay, just copy this function and paste it in here. And you need to pass two parameters to the function, one for x coordinate and one for the y coordinate. Just type in 5. This is enough for our example. And then we need the write string function. There I will call the whole, I will copy the whole function because we will change the parameter one by one. Copy the function, go back to main.c, paste the function in here, and let's have a look at the single parameters. First of all, we need to pass a string we want to display. So let's create a string. Let's create a string here at the beginning of the main. It's just a character array. Character my text, then leave this angle brackets, this empty angle brackets, equals to hello OLED. That's it. That's used for my text to display. Now scroll down to the OLED function and just insert here the array we've created right now, the text array or the character array we've created. Now we need to define the font. So to see what we actually can put in here, just control and click to the font depth, to the type of this parameter. Okay. And now just copy one of these fonts. Don't mind if you see this grayed out, like in my case, because we already defined the fonts in the config header file. I think this is just a small bug in the CubeIDE, but don't mind, it should work without any problems. For example, let's copy this font 6x8, or copy the font 7x10. It's a bit bigger, better to see. Copy the font, go back to main.c, and just paste the font in here as parameter. And now we need the color, and I can tell you the color, as you can see in this preview, is black is no pixel and white is pixel turned on. So we need white. So pass here white as parameter. And as you can see, there is a return value from the function write string. It's either the termination character that will be returned if the output of the string or the writing of the string was successfully, or it's the character itself that causes a problem, as far as I can remember. In any case, we just need a placeholder for the return value. And therefore, we will create a character variable, character read well return value. Copy this and place it here. Oops. Right. Now we set the cursor, we write the text on the OLED, and then one final important function call we need to do is the update screen function. Then after we call the update screen function, we should see the text on the display. Now let's save everything, rebuild, don't forget to rebuild, and then start the debug again. But before you start, ensure that your breakpoint is at the line of the init function call. Now start the debugger. Okay, click resume or play. Now the debugger stops at the init function line, jump over the init function, and as you can see, the display turns off again, because after the initialization, the default state of the display obviously is all pixels turned off. Now set the cursor, write the text on the OLED, and now update the screen to show the written text. Okay, that's it. Now you are capable of writing your own OLED project. I will cover some other functions of this OLED driver in a later video, but for this video we are finished. Okay, that's it for this video. I hope you enjoyed writing the code and creating the project with me. If you have some tips for me how to improve videos like these, please let me know it in the comments. For the future, I plan to do more videos where I show you how to write a driver for a certain sensory or something like that. So if you have some wishes regarding the sensory you want to see me writing a driver for, please write it down into the comments. Could be an STM32 project or also an Arduino project. Okay, so have fun. See ya.